Let's solve some problems for Boyle's and Charles' law. The first one, which is Boyle's law, is calculate the volume of a gas at 5.75 atmosphere if it occupies 5.14 liter at 2.49 atmosphere. Now remember, Boyle's law is P1 V1 is equal to P2 V2. It's really important to identify your initials and your finals. Once those numbers are set, then your calculation would be fine. So the best thing to do is to go ahead and write those out. So for example, calculate the volume of a gas at 5.75 atmosphere, which means you don't know the volume. So let's give that 2 is equal to what, which we don't know. And the pressure 2 then is 5.75, occupies a volume, so V1 is 5.14 liters, and then the pressure 1 is 2.49 atmosphere. Okay, so make sure your units are all consistent. So then we know that we need V2. Okay, once you know that, you can set up your cross multiplication from this equation here, the P1 V1 is equal to P2 V2. So V2 is equal to P1 V1 over P2. Okay, and all you need to do now is plug in all your numbers, which pressure 1 is 2.49 atmosphere, volume 1 is 5.14 liters, and divided by the second pressure, which is 5.75 atmosphere. Now, before even writing out the answer for this problem, let's just go ahead and look at it once more. It says calculate the volume of a gas at 5.75 atmosphere if it occupies 5.14 liters at 2.449 atmosphere, which means that the first set of condition, the pressure was lower and now the pressure is higher. And remember the relationship between pressure and volume, it's inverse. So if one increases, the other one should decrease. Okay, and so here, if the pressure is increasing, the volume should decrease. That should give you a little bit of an idea of what kind of number you should get. And after calculating all of this, you should get 2.25 liters, which is perfect because yes, if the pressure has increased, the volume, which is 5.14 initially, should decrease. Okay, and so 2.25 liters is our final answer. Make sure to include your units. Okay, the next one, what will be the new pressure of a 6 liter balloon if it had a pressure of 748 torr when the volume was 4.50 liters? Again, the relationship here is between torr and liters, which means that this is also Boyle's law. So again, P1 V1 is equal to P2 V2. That's going to be our equation. And again, we go ahead and write out our P1 V1 and then P2 V2 values. Okay, so initials and finals. So pressure 1 is 748 torr, and at that pressure the volume was 4.50 liters. What will be the new pressure? So new pressure is what we are calculating of a 6 liter balloon. Okay, so again we are increasing in the volume. If the volume is increasing, the pressure should decrease. Okay, so now we know we're calculating P2. So looking at our equation, P1, let me start another way. P2 is what we are calculating for. So P1 V1 divided by V2. Okay, that should be our equation. So let's plug in the numbers. P1 is 748 torr. In this case, we don't need to convert the units from torr to atmosphere because they will cancel out. Okay, so we don't need to. Again, the same thing with the liters. If one was milliliters and the other was liters, then we have to change, but otherwise we don't have to. So then 4.50 liters divided by V2 is 6.00 liters. And once you do the calculation for this wonderful problem, then your answer here, the pressure should be 561 and it should be torr. So yes, our volume increased, so the pressure has decreased, okay, for us. Okay, so that was Boyle's law. The next question is, a sample of gas originally occupies 29.1 liters at 0 degrees Celsius. What is the new volume at 15 degrees Celsius. Now this is a relationship between volume and temperature. So this is Charles' law. So which means that our equation is going to be V1 over T1 is equal to V2 over T2. Now it's really important when we get into temperature numbers that we change the units, okay, from Celsius to Kelvin, all right, because you don't want to work with zeros. If you work with zero, everything will be zero or infinity, okay, and so 0.0 plus 273, so that's 273 Kelvin, and then 15.0 plus 273, and that will give us 288 Kelvin. Okay, so once you've converted this to Kelvin, now we can work on finding out V1. And so V1 is 29.1 liters, and T1, the temperature, is 273 Kelvin, and then V2 is what we are calculating for, and then T2 is 15 degrees Celsius, which is 288 Kelvin. Okay, so V2 is what we are calculating for. So again, rearrange your equation to give volume, and then it is V1 times T2 divided by T1. Okay, that is your rearrangement. The volume is 29.1 liters. The second temperature is 288 Kelvin. Please make sure, this is the most important thing, okay, making sure your initials and finals are correct. And then your initial temperature is 273 Kelvin. Okay, and the relationship between volume and temperature is direct relationship. So if the temperature has gone up, then our volume should have also gone up, technically speaking. So let's do the calculation, and once you do this, it will come out to be 30.7 liters. Okay, and so yes, our volume also went up, although it's a very small amount. It went from 29.1 to 30.7, but it's still an increase, okay, with the increase in temperature. So that was Charles' law. Then let's go ahead and do another one, okay, and here the question states, a sample of hydrogen gas occupies 692 liters. So if you want, we can go ahead and start writing the numbers themselves. So occupies 292 liters, so which means volume 1 is 692 liters at 602 centigrade, so which means temperature 1 is 602 plus 273, that will give us our Kelvin. At what temperature, so which means T2, at what temperature will it occupy a volume of 300 liters? So volume 2 then is the 300 liters. Okay, so temperature is being asked, and we need to calculate that in degrees Celsius, okay, once we finish the calculation. So now our final our temperature here is 875 Kelvin. All right, so then our equation, beautiful equation, V1 over T1 is equal to V2 over T2. We are calculating for T2 over here, so which means cross multiplication, and that will give us T2 is equal to, take T2 up here, so which means that V2 times T1 divided by V1. Okay, so that is how it comes around once you rearrange the equation, cross multiplication. Okay, and then so now volume 2 is 300 liters, and the temperature, first one, is 875 Kelvin divided by the first volume, and the first volume was 692 liters. So liters, cross out, and then our final answer is, for this one, 379.3 Kelvin, but we need to give our answers in Celsius, so we're going to go ahead and subtract 273 from this, and that will give our answer to be 106.3 degrees Celsius, which you can cancel out the 3 because we need the answer in 3 significant figures. Okay, so again, let's look at the answer and make sure it makes sense to us. the gas was 692 at 602 degrees Celsius. Okay, so if we decrease the volume from 692 to 300, then at that point the temperature should also decrease, okay, because they are both directly related, and so the temperature has also decreased from 602 to 106, okay, degrees Celsius. So that is, yes, a lot of decrease there.